You're watching Telecom TV from the MEF16 event in Baltimore. And it's time now for our panel on open networking. And I'm joined today by three guests, two of whom are old favourites of Telecom TV and one of whom hopefully soon will be. And if I can get you all to introduce yourselves.
Shahar Steif, BCCW Global. I'm also at the MEF board for the past 3 years and a collaborator in crime with Raghu here as co-chairs of the Technical and Operations Committee.
Thank you, Shahar.
Pascal Menezes and the CTO of the MEF, so my title is pretty short.
And next to Pascal.
Raghu Ranganathan from Sienna, and I'm a principal and distinguished engineer within Sienna in the office of CTO. And I represent Sienna in the MEF at the board level as MEF director, co-chair with Shahar on the Technical and Operations Committee, and I'm also a MEF fellow leading the effort in MEF.
Great, well, good to meet you, Raghu. Can I start, though, with Pascal? And how about you give us an overview of what the MEF Forum's position regards open networking?
You're seeing everything's being disaggregated. No one wants to be caught into a monolithic vendor solution anymore, so they want to disaggregate things so that they can take the best of breeds. And so when you think about that, open APIs are critical. So really what's going on in networking, we're moving into a world of software driving the network. Obviously, it's the big trend you've heard all over. And with that, software needs APIs. So we have APIs down talking to all the different technologies and networking equipment. And we have APIs that have to talk between operators. And we have APIs that have to talk up into the business systems. So at the end of the day, when we mean open networking, we mean open APIs. Some people think it's open source code, but not necessarily that's true. It could be closed source, open source, it really doesn't matter, but the APIs are open. That's critical.
Who's really asking for this? Is it the vendor community, or is it the service providers who are insisting that this needs to be done?
It needs to be done because we've got multiple systems and multiple players around, both internally and externally. And today we're doing things manually, which means we convey information manually from one system to another, either internally or externally. It could be a swiveling chair, a person who reads the request on the ordering platform and then turns that into configuration command on the delivery platform. But it can also be an inter-carrier stuff, which is today done through forms, through paperwork, through fax, through whatever. APIs simply turn that into machine doable activities. The machine just talks to another machine through an interface. It's just an electronic interface rather than a human interface.
And yes, please go.
No, I think from a service provider perspective, it's very important to realize they have a very heterogeneous sort of environment, if you will. And the way they can think of introducing more agility into operating their networks, one could be thought of as creating a suitable sort of an abstract view that is common, and therefore you have these APIs that can allow you to program the network. And if you generally ask the question of open networking, it's not just about open hardware, but it's also about open software working together via these APIs. That is the most critical puzzle, if you will, that you need to solve.
So not just hardware, not just software,
but the interworking of those two together via these APIs, not just within a domain, but also across domains, as Shahar was talking about.
So are we also looking to enable faster development and speed up the whole process, as well as the overall interoperability and getting it all working? Are we looking at a speed issue and a need for the industry to work faster and fail faster at times if needs be?
That is an important aspect of the problem statement, which is if I need things to be more agile for time to revenue, for introducing new features, capabilities, or functionalities that my customer demands, what is the best approach to reaching that end objective? And one way to do, as Pascal was saying, is it's about creating that framework of transitioning from a hardware-centric view to a software-centric view, where you create your services in software, which allows you to do it in almost near real time as the customer demands it.
Yeah, I mean, that's absolutely. I mean, if you look at what you do with music today, right? When you're creating music today, right? You can create it all in software now, and then render it out and play through hardware. Same kind of ideas. Can you create services all through software? Can you build out your services, orchestrate them all done through software, and then obviously the packets have to flow in actual hardware. But all of that's constructed in software.
But as well as this, it's going to change cultures as well, surely, within providers.
It is going to change culture, obviously, because when we're moving away from a hardware-based platform or a hardware-based culture into a software-based culture, where things are not done by configuring devices manually, but by letting one device configure the other through an electronic means, an API for this structure, we'll need to go through some serious changes culturally as well. We need to move away from a lot of manual approval processes that we used to have in the past. We'll need to pretty much think of everything in advance and then let machines just implement stuff instead of inventing each and every solution manually for each and every customer request, which is the way we typically do business today. That's a totally different culture. I mean, people need to shift roles within the organization. Solution engineers will no longer handle current requirements. They will actually need to try and anticipate the requirements and build the solutions in advance, which can then be tailored together into a bundled solution that can be offered to a customer. I won't say even offered to a customer, activated by the customer for their own use in real time.
Yeah, and I think, if you step back and ask a very simple questions, why all this? It's fundamentally because operators like PCCW have to think about building networks at scale. AT&T mentioned 60% of the traffic in the network is video. The amount of traffic with Internet of Things. So if you look at the enormous amount of scale that needs to be handled, automation not just about network programmability, but automation in terms of all the back office processes have to occur in sort of conjunction, if you will. And that's very, very important.
That's really what the lifecycle service orchestration is about. It's that capability to
Exactly.
program, whether it be the network or program between operators or communicate between operators. That's really the essence of lifecycle service orchestration.
So we're hearing the work that's coming out of MEF Forum. We're hearing a lot about Open LSO and also Open CS. Can you give us an overview of what those two are, or what the main thrust of the work is, and then maybe go into some more detail as to who benefits and why?
Absolutely. Open LSO is come in just recently, where we really want to show a reference implementation of lifecycle service orchestration. So we're working with a number of open source projects like OpenL, and we're hopefully with Ecom too, and we'll be able to show that working. But then, in Open LSO, there are also vendors who are members who build LSO, lifecycle service orchestration. They're completely closed. And so we want those members to also be able to show their stuff working in Open LSO, right? So when you think of open, doesn't mean open source, it means the APIs are open. So whether it be closed source or open source, it doesn't matter. So
And that's an important point. When we talk about the functionalities that are there in a network, we talk about an LSO reference architecture. What did we do there? We specified the entities and the interfaces between those entities. What we as a community want to do is specify the behavior of those interfaces, thereby allowing innovation to happen inside those entities on either side of the interface. That's a very important philosophy that we need to be careful about, because then, as Pascal was mentioning, these entities could be open source or closed source, but the APIs are standard, open, and interoperable.
So long as the APIs are open, that's the key.
It allows for innovation.
And the reason we did the reference implementation was so our members can take it and commercialize on it, right? So when we try out these use cases, as these gentlemen here are building out the business requirements, the use cases, specifications, the service definitions, we have to be in a very iterative model, and so we have to move fast. So we have to try to take those ideas, test them out, see what sticks, see what works, give back feedback, and then members can take some of that and start innovating around it, because we need to move really rapid innovation cycles. We cannot be, in the old world where, because we're in a digital economy. Everything's about agility.
There's old world and new world, and I think those two will still need to work together and to live together, because eventually open source can only implement as good as the spec it implements, or I would say rephrase that, open source can only be as good as the spec it implements. It can implement a spec very quickly and provide a very quick proof of concept and a very, very quick turnaround for actually implementing a spec. But if there's no spec, you're developing something that's proprietary. And then instead of being vendor locked, you're open source locked. With a proprietary open source, it's just the same lock-in. So the fact that it's open source doesn't mean you're not locked to it, because if you've programmed all of your systems to support that specific open source, and then you're locked to use that version of open source. If someone else comes with something different, your open source wouldn't really be of help. So the real importance is the touch points between systems. Those need to be standardized. How you configure your own system, how you configure your own domain, what are you using, what open source you use there, or closed source, is entirely up to you. It is important that the touch points between processes, between entities, between elements be standardized. Now, an API, after all, is simply a means of communicating between two devices. It's just a means of communicating. You could have used other methods except for just for API to transfer bits from one side to the other. The really important thing is to make sure that the processes on both sides match, the touch points between the processes on both sides match, and the information models on both sides match. Because if you have the process done correctly on both sides and the information model done correctly on both sides, the API pretty much writes itself. You already know what you need to convey from one side to the other. You just need to agree about the sequence of bits from one side to the other, and that can be easily done through a catalog or whatever you use to actually define the API.
What needs to be done to standardize these specifications? How do we achieve what providers say they need to have?
And it's similar to how you and I communicate. We are able to communicate in the language of English because we have a vocabulary. And likewise, when PCCW needs to talk to AT&T or another provider, they need to have the same dictionary from which they select the words, form messages, and communicate. And if both of them are using the same dictionary or some translator, they'll be able to communicate. I think that is the most important aspect, is trying to sort of come to an agreement on what is it that I need and how do I express that need across that interface. And that's the most important aspect.
So what is the MEF Forum's plan to develop this work and evolve it and take it forward?
Excellent.
So this is why we did the open initiative, right? Yeah. So these gentlemen here are working in the spec side of the house. They are working very diligently to deliver these use cases, these service definitions, operational threads, how things should behave. And then what we want to do in the open initiative is take that and make code out of it and develop it fast. And as you can see, we have our hackathon over here. Yeah. So we have developers trying some of these ideas, writing code, delivering these APIs, showing them information flowing across, communicating properly. And we're hopeful to even launch now an always-on development community, is what I'm trying to get to next. And so the idea of an open initiative is to show reference implementation, again, for the code working, these ideas working, and then let our members take that and commercialize it.
And it's not just for OpenLSO, it's also for OpenCS,
yes,
where you want to be able to orchestrate service behaviors that are implemented on open source platforms or platforms that support the behaviors that we want as defined in MEF specifications, for example.
Including closed source platforms.
I think what MEF really does is pretty much work in 3 or maybe 4 trajectories. And in order to achieve this nirvana of end-to-end orchestration, we have to standardize service definitions, which MEF has been doing for 15 years now. And I think MEF has been doing an excellent job on that, primarily on Ethernet, but now we're moving into cloud and into IP, hopefully into mobile as well. So that's one trajectory. The other trajectory is the process, because we need standardized process as well. And MEF has been doing that for the past 3 years or so. And the third one, trajectory, is the orchestration, which puts those together and creates the touch points during the process between the various systems through which the components of the service, the information that describes the components of service, can be transferred from one entity to another. And then we have the open initiatives, which are like reference implementations that provide feedback on how good does it actually work, can it really work, what are the challenges, what's missing. So I think MEF is probably the only organization in the industry that handles all four together. There are many other organizations which are doing an excellent job on a very specific implementation of a very specific problem statement, like provisioning of a service or orchestrating a cloud service. MEF is the only organization that actually looks at it from all directions, from service specs, from process specs, from orchestration perspective, as well as the actual implementations through the hackathons or through the open source initiatives.
Yeah.
So Pascal, it looks like you've got a very clear role here and a very clear path of where you need to be.
Yeah, I mean, we've come a long way, I think, in 9 months, since I've been involved. It's been about 9 or 10 months, and there was no open initiative, and we've defined the MEFnet environment where we have an always-on environment where all the bits are loaded. We have our hackathons, we have our OpenCS, OpenLSO now initiatives where we can try all these ideas out. And I got to say, there is very few organizations what MEF has done. MEF has built over 15 years an $80 billion market. The sole authority that's driven that market by the specifications, certifications, has been MEF. And so the goal is, that market is still growing, as you saw in some of the sessions. People are making a ton of money and continue to grow. Question is, can we leverage that and evolve that into even other more revenue points or services? And that's really the goal of what we're trying to do with these new services and so on. So.
Right, great. Well, gentlemen, fascinating discussion. Very, very clear about where we're going with open networking. Thank you all very much indeed.
Thank you.
Thank you.